So suppose we have some stuff and we want to build some circuits. It's probably a good idea to know what this stuff is, and also what it's called. We have here some batteries, wires, a switch, lamps or light bulbs, resistors, a variable resistor or potentiometer. It's like a volume knob or the thing that controls the intermittent wipers on your car. We have a voltmeter and an ammeter. Oh, and technically this is not a battery, this is a cell. The word battery means group, so in military history a battery of cannons is a group of cannons. This is a battery, and so is this. However, we use these terms interchangeably a great deal, and it won't matter which one you draw in a circuit if you're asked to do so. Speaking of drawing circuits, here is a very simple circuit consisting of 2 cells, 2 wires, and a light bulb. It would be ridiculous if I asked you to draw this circuit for you to draw something like this. This drawing is sloppy, nearly impossible to read, and took way too long to do. Nothing about that is a good use of time. To that end, we created a set of symbols that we use to draw circuits so that we can make neat, orderly, organized drawings. Regents, you can find these on your reference tables. AP, you're going to have to memorize them. A proper drawing of this circuit would include a battery, a wire going to your light bulb, and then a wire going back to the battery. Note that you can use however many loops you want, including only one for a light bulb. But we did make a mistake that if you look closely you'll see. The left side of these batteries are positive and the right side are negative, so we have to switch this around. Yes, we will be that picky about battery orientation. Oh, and if we want to add a switch to this circuit, it's as easy as adding a switch. This next circuit is similar to the previous two, but now we've added a resistor as well. Don't add the resistor on the left side of the circuit just because that's where it is physically. You want this to be nice and neat so you can draw it like this. Check out this mess of spaghetti. The wires come out of the battery and then split into 3 paths, a yellow path with a resistor, a green path with a resistor, and a red path with a resistor. They then combine back together and go into the other side of the battery. Just as there are neater ways to draw circuits, there are neater ways to build them. Let's grab those 3 resistors and simplify things down with a little twist. There, that's better. There's nothing complicated about this. If the circuit has 3 branching paths, then you draw it with 3 branching paths. You could also draw it like this. They're both the same circuit. So it turns out that in order to measure an electric circuit, you actually have to add things to the circuit, and that changes the circuit. You can't measure it without changing it. So part of our goal is to measure things as precisely as possible while changing things as little as possible. So I've got here an old school voltmeter, okay? This voltmeter doesn't look very special. It's old. It's got a place where you can hook up wires. You could also hook them up back here if you wanted to. There's a little plastic knob on it. It doesn't look like much, but it's got a little needle dial that says volts. And I have an ammeter made by the same company that, except for the label, looks exactly the same. Voltmeters and ammeters, exactly how they work, we will talk about when we do electromagnetism, but they are almost identical in terms of how they are made. The huge difference is that the voltmeter has an enormous resistor in it, so it blocks all but a tiny trickle of current through it. And an ammeter has no resistor in it, so it's essentially a piece of bare wire in terms of how it behaves in a circuit. It's going to do nothing to restrict current flow. And to that end, ammeters have to be placed in series with any current you want to measure. The current has to flow through the ammeter to measure it properly. Voltmeters, though, if you tried to do that, it would shut the whole circuit down because their resistance is so high. Voltmeters are always placed in parallel. So you have a resistor, and then you hook the voltmeter up on either side, and the voltmeter steals a tiny trickle of that current in order to measure the voltage across without affecting the current through the resistor very much at all. As a general rule, we're going to assume that both of these devices are at least close to perfect so that they don't have an overall effect on the circuit. In real life, you should keep in the back of your mind that nothing's perfect and you do change the circuit when you hook up meters to it.